maybe. Oh my gosh, this thing's right in my way. Okay, sorry. This is way harder than it has to be. There we go. Cha, 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 cha. And there I am. Hello. Okay, so now we're ready. We're ready to go. I like to, remind you I'm a human. I'm right here. So, let me just set myself up so I'm at like writing at an angle. It's actually delightful not having a mask on right now. Okay. So we have two things in the problem set. It was the last four problems that we just hadn't done yet. So let's clear that up. The first is sketching a point. Okay. So I'm sketching a point. The point is a complex number. So a complex number has a real part and an imaginary part. So you're probably saying, like, how the heck do I sketch that? So we basically think about our axes a little bit different. We don't see the x-axis and the y-axis. Now, when we're talking about complex numbers, we say that this is the real axis. Sorry. And this is the imaginary axis. So now that we're talking about a different type of number, now our axes are different. So just as a heads up there. So when I'm graphing, it's pretty quick when you actually understand what's going on. On the real axis, I look at the real number. The real number is 5. So on the real axis, I'm going to go over to 5. Done. On the imaginary axis, I think about the imaginary number. So that's negative 6i. Since it's the imaginary, we assume the I is with it. So I'm just really going to see where negative 6 would be. 1, 2, 3, 4, 5, 6. So if I have 5 on the real and negative 6 on the imaginary, my point would be right there. That's it. So it seems like it's going to be all sorts of complicated with that I, and things might get a little crazy. It doesn't. It's just thinking about changing the way we think about our axes when we're talking about complex numbers. So just think about it as a 0.5, negative 6, because your axes are different. So just another quick one just to visualize. So if I said graph negative 2 plus 5i. So once again, graph, this is real, this is imaginary. So on the real axis, I need negative 2. So I'm just kind of sketching out where that would be. On the imaginary axis is 5i. Once again, I'm just dealing with kind of the coefficient of 5 because the I would be taken into account when it's imaginary. And then I go to negative 2 on the real, 5 on the imaginary, and that gives me my point. And that's that. That's about as crazy as those get. So when I'm thinking, I have my little problem set in front of me. So I'm looking at it, numbers 102 and 103 were that concept. So we hadn't gotten to those on the last page yet. So you should now be able to do those. There you go, magical. So the other thing on the problem set was absolute value of complex numbers. So let me show you how to do that quick. Once again, it's a nice little formula you're just plugging into, and it's actually something you kind of know how to do already, which is nice. So the absolute value. So just as a reminder what absolute value means, it means a distance away from 0. So we're talking about something being from 0 on a plane, right? There's two axes. So think about if I said, what's the absolute value of this? You would say, oh, from here, it's the distance to there, okay? How would I find that? Think about like a little drawing a triangle. You find over and down, and that's just the hypotenuse. It's just Pythagorean theorem, right? It's just a fancy formula for Pythagorean theorem. So to find the absolute value of a complex number, we plug into the formula the square root of a squared plus b squared. And that's it. We're just going to plug into the formula and then we're done. So if I said, hey, what's the absolute value of 8 plus 15i? So what you would say is, okay, this is my a, right? Because that's just my real number. The b is what's in front of I, the coefficient of I. So you don't actually take I. So b is just going to be 15 in this case. So we're going to plug it in. So we would have the square root of 8 squared plus 15 squared. So once again, there's no i's in this formula. You're taking whatever's in front of I. That's B. So from there, you're just going to plug in, use your thing. I think that's 289, excuse me, I was off. Square root of 289, and the square root of 289 comes out to be 17. So if you were to sketch that point and then find its distance from 0, it would be 17 units from that origin. So a pretty quick formula, not too bad to plug into. So let's just try one more quick one. What's my other one? Let's do the absolute value of -7 minus 24i. Yep, just plug it in. Just be careful that you always use parentheses, especially when you're using a calculator. When you are squaring a negative, that does make a big difference. So we're going to do the -7 squared plus -24 squared. When I throw that in my calculator, that's going to come out to 625. And I know now that I have to take the square root of that, the square root of that is 25. So that means that point is 25 units away from the origin. That's about as crazy as it gets. So nothing too crazy there. There is, I believe there's one sketching on the take home, and then there's one absolute value on the take home. So just as a heads up, if you want to try one or check your answer, this is the problem set. The last two problems are absolute value. So there you go. So you can try those. Always good practice. And you have the answers to check that you are doing it correctly. So that was the new stuff. And then I was just looking back at the problem set because, you know, fun times. And we were working on solving equations using square roots the other day. I think that's what we did Friday. So, you rearrange, you take square roots. It's all sorts of fun. We make sure that if there's a negative underneath the square root, there is an I in our answer. We make sure we always put a plus or minus in front. So things like that. There were two that I thought were maybe a little tricky, so I wanted to do those two with you. So there aren't ones this tricky on the take home, but we might see ones later like this. So I just don't want you to be stuck. So I'm in the problem set. And I'm looking at number 99. Okay. I'm sorry. This has a flaw. Okay. So we have a nice little equation going on. So we have 2x minus 1, 3x minus 2 equals x minus 5, x minus 2. And we want to solve this equation. That's exciting stuff. And we've been solving using square roots. So we notice right now, this is not the form that we need. So we have to do a little simplifying before anything else, just to get it to how we need it. So I'm going to start by just distributing both sides and then kind of trying to combine and see what I get here. So if I distribute on the left side, I'll get 6x squared minus 4x minus 3x plus 2. That would just give me 6x squared minus 7x plus 2, right? Just to simplify as I go here. And then over here, I would get x squared minus 2x minus 5x plus 10, which would come out to x squared minus 7x plus 10. Delightful. Now, when you're solving with square roots, you want your x squared, your quadratic terms, on the same side. So I'm going to move this x squared over here. And we'll get 5x squared. Perfect. And basically I want anything else on the other side. So I really do want to isolate that x squared. That's my main thing. So anything else on this left side, I'm going to move to the right. So when I move my linear term, what I notice happens is they cancel, right? Because negative 7 plus 7, I have no more linear term, which is good because if that was there, I couldn't use square roots. So that's a good thing. But I can move this constant as well. Okay. So that's looking better. I would just divide both sides by 5. And then take the square root. Please make sure when you take a square root, you do write plus or minus. Plus or minus the square root of 8/5. So here's the problem. We never leave answers like this. So we always like things simplified. We never want the square roots to be in the bottom of a fraction, or we never want the square root of fractions. It's just kind of a weird thing. It's not simplified all the way. So I wanted to show you how to do this because I'm not sure how much you guys did with radicals last year. Once again, I'm at the point like we're just going to assume you've never seen it because last year was such a bit of a disaster. So if you see an answer like this, we don't leave it like this. Okay. So I have plus or minus the square root of 8/5. We always rewrite it. So what we can do is, since you have the square root of a fraction, you can break it up to be the square root of the numerator over the square root of the denominator. So basically we split it up into two separate radicals. Please, you're going to notice my entire way I'm just keeping that plus minus with that because we always need those two answers. Now, if you remember when we talked about it with division, we can't have radicals in the bottom of a fraction in the denominator. That's why we can't have i's there. So we took care of our i's. Same thing, we have to do the same thing here. You take what's in the denominator and you multiply by that over itself. Just like when there was an I in the denominator, you multiply by I over I, same concept. So I end up with plus or minus. When I go straight across, I get the square root of 40 over the square root of 5 times the square root of 5 is just 5. And then I always look for radicals. Can I break this down? And I can break down 40, right? That would be 2 root 10. And I think I'm good, right? This doesn't reduce. I have my plus or minus. This is all set. So x is going to equal plus or minus 2 root 10 over 5. What a beauty. So that was a little different. And once again, I know we were a little rushed last week, so thank you guys have been good sports. So thank you for not like, I don't know, rebelling against me at this point. But I just wanted to show you that. So if you had tried it, great. If you hadn't tried it, then write it down now. I'm going to do one more with you. I'm going to do 101, and then we'll talk about what your options are for the end of class and what you would like to do to kind of get some work done. That's it. So let me do 101. It has a similar step to this, so I do it again. (101). All right, let me write the problem first. X times 3x plus 2 equals x plus 1 squared minus 6. All right. So we got this beauty, and same idea as the last one. Okay, this is great, but it's really not in like the form that I need. I need my quadratics together, and I need everything else on the other side. So we're going to have to distribute and kind of move stuff around. So on the left side, I'll distribute. I'll get 3x squared plus 2x. On the right side, just as a reminder, when I say x plus 1 squared, don't square everything. It means x plus 1 times x plus 1. So if I distribute that out, I would get x squared, and then I would get plus 1x plus 1x plus 2x. I'll just combine that in the brain ski there. Plus 1 minus 6. Okay. So our main goal is quadratic terms to one side. So I'm going to move the x squared over here. Everything else to the other side equals. So I'm going to move this 2x over here. And what a beauty. The linear terms, the x's cancel, which is what we need if we want to use square root. So that's a good thing. And then the last thing, I just have these constants over here. So 1 minus 6 gives me negative 5. Okay. Divide both sides by 2. Beauteous. Square root of both sides. Okay, so now I'm getting towards the end. I want to make sure I'm good. The first thing, if you take a square root, put a plus minus. You need two answers. Just a reminder why we need two answers. When I'm talking about a quadratic, it has two intercepts, right? So that's why there's always two answers. You need to do the plus minus. Now, what I notice is I have a negative under this radical. So I'm going to take care of that right now. Instead of having a negative underneath, which we know we can't have, I'm going to write an I. Right? So that I is representing the negative under the square root. And then we end up with the square root of 5 over 2. Hey, that looks exactly like the one we just did when we said we don't want to write answers like that. It's just not simplified. So I'm going to kind of simplify as I go. I'm always in front of everyone. I'm going to write plus or minus I so I don't lose it. So I'm going to rewrite it as plus or minus I, but I'm going to split it up. So I have the square root of the numerator over the square root of the denominator. We said, well, we can't have a radical in the denominator, so I'm going to multiply by, since that's square root of 2, I'll do square root of 2 over square root of 2. And I end up with plus or minus I. When I multiply across, that would give me square root of 10 over 2. Then I'm done, right? I can't simplify square root of 10. I can't reduce the fraction. There's nothing else fancy going on. So x is going to equal that. And that, my friends, will be your final answer. Sometimes I'll put the I with the numerator. It doesn't matter. As long as the I is somewhere, you're good. Well, don't put it in the denominator. But if you can write it as plus or minus I root 10 over 2. But same thing, right? Because I is technically over 1. So just a few little things I wanted to show you. There aren't any that complicated on the assessments, little take-home assessment you guys are going to be getting. But just so you've seen it, because we might see it in the future. We'll try to keep kind of building. I know we're a little rushed here, so sorry about that. But hopefully the Shermans stay healthy. That's what my goal is at this point. All right, so give me 1 second because I want to stop share. Oh, sorry. I want to stop recording.